Hello, hi dear students, greetings for the day. Welcome to Classroom TV. Today we are going to start a very interesting chapter, that is visualizing solid shapes. So this topic mainly deals about the solids, like solid objects, they appear in two-dimensional as well as in three-dimensional. So this topic mainly deals about the objects in three-dimensional. So without any delay, let's begin the class. Let us see now. Before that, first you should understand what is a solid actually. You know basically what is a solid actually. So an object having length, breadth and height, that is called a solid. So an object having length, breadth and height. So three dimensions. So this is a three-dimensional solid. So solids generally they have a fixed size and fixed shape. They have a size and fixed shape. So these three-dimensional objects, sometimes we also call them as two-dimensionals. Say suppose like a square, okay, even a rectangle, even a circle, a triangle. So these are all comes under two-dimensional figures. Whereas a cube, cuboid, sphere, cylinder, these are all comes under three-dimensional. Clear? So let us discuss now. So what is a solid actually? So an object that occupies space and has a fixed size and shape is called a solid. Clear? So what is a solid? That occupies some space and which is having a specified shape and concerned size, some size. So that is what we say an object here, an object, that is what we say a solid. Since solids have three dimensions, what they are length, breadth and height, so they are also called two-dimensional as well as three-dimensional solids. Clear? So what are 2D figures here? Like a triangle, rectangle, circle, these are all comes under 2D figures. Whereas a cube, cylinder, cone, sphere, like that, they are all 3D figures. Is it clear? Okay. Now drawing solids on a flat surface. Okay, so how to draw solids like cube, cuboid, how we can draw them on a flat surface. Actually, it is very easy to draw 2D figures on a paper because paper itself 2D. Okay, so it is very easy to draw any 2D figure on a paper as the paper itself is 2D. But for 3D figures, it is a bit difficult. To draw 3D figures on a paper, it is a bit difficult. So, to give it the same look as if we were viewing the original one, so to draw the 3D figures, we have mainly two ways. Clear? So let us discuss what are the two methods that we can draw 3D figures. So the first one is oblique sketches. Okay, say suppose we are drawing a cube, we are drawing a 3D figure cube by using oblique sketches. So what we have to do here, this has to be done in 3 steps here. In the beginning, draw the front view of the cube, whatever the measurement of the cube is given. So first we have to draw the front view. Okay, so step 1, you can have a look on this diagram here. So this is the front view of a cube, taking the measurement as 5 units. So draw the front view of the cube using measure of the side given. So then, what is step 2 here, if you can observe? From each vertex, okay, from each vertex, draw lines backwards such that the angle is 45 degrees. Okay, from each vertex, draw the lines here, making an angle 45 degrees. Now, what is important here? Draw the edges such that it is half the original measure. Okay, you have to draw the edges, these edges, you have to draw them such a way that they are half of the original figure, original measurement. Understood? What is step 2? After drawing the front view, from each vertex, draw these lines, I mean to draw the edges making 45 degrees. And these edges, they have to measure half of the original. Is it clear? And then step 3, just join all the edges at the back. Okay, so after drawing these, just join all the edges at the back. That means here it is 5 units now, so the half of the original, in the sense it is 2.5 units. Understood? So what are the 3 steps? First, to draw the front view, and then from each vertex with an angle of 45 degrees, draw the edges. What should be the length of the edge? It should be half of the original measurement. Here there's 5 units now, so half of 5 units, it will be 2.5 units. And after drawing them, just join the edges at the back. So this is how we can draw oblique sketches. Then what is the second one? Is a very, very important one. Isometric sketches. See, what are these isometric sketches here? See, we are seeing some dot sheet here. That is what the dots, what you are seeing, that is an isometric dot sheet. So here, isometric sketches can be made only using isometric dot sheets, or of course we can call isometric grid sheets. So here, if you can see here, these dots, see what is this? These dots, they are appearing on the sheets, they form small equilateral triangles. See, any three you take. So they are appearing like small equilateral triangles. Clear? Now here, in isometric drawing, all vertical lines are drawn straight. All the vertical lines should be drawn straight, but the horizontal lines will always be slightly tilted. Horizontal lines will always be slightly tilted. In such drawings, we will be taking the actual measurement, not like earlier. Earlier in oblique sketches, we will be taking half of the original, but here we have to take the actual measurements, or you can say proportional measurements of the objects, unlike oblique sketches. Is it clear? So in oblique sketches, the measurements were not accurate. Understood? So remember 3 things here. In isometric dot sheets, the dots, they are like small equilateral triangles. And remember here, the vertical lines are drawn straight, but the horizontal lines will always slightly tilted. Okay, let us draw one figure by using isometric dot sheet here. Say suppose we are drawing a cuboid here. So how to draw cuboid? Whose length is 6 units, breadth is 2 units, and height is 4 units. Okay, we need to draw a cuboid of length 6 units, breadth 2 units, and height 4 units. Let us see first, draw the 2 units here, 1, 2. See, it is a vertical line. Clear? So, this is the step 1 here. This is the first step. And after that, what we will do here, the length of 6 units, it is 1, 2, 3, 4, 5, 6. So this is the second step. And in this way, again 2 units. Is it clear? Understood? And now, the third step, what we are doing here, see, we are just drawing the parallel lines to the length. See, this is what the earlier diagram. Now we have completed the parallel line to this. And we will draw whatever the sides remaining, we draw the parallel sides. So this is the fourth step. Draw all the remaining parts parallel to the opposite side. Is it clear? So this is how we can draw an isometric, we can draw a cuboid of given measurements by using isometric dot sheets. Very easy. Now, let us see here. Draw the following 3D figures on the isometric dot sheet. So we have to draw the 3D figures on isometric dot sheet. See here, this is the figure given here. So let us see how we can draw by using isometric dot sheet. See? Yes. So this is what drawing the by using isometric dot sheet, how to draw the given figure. Is it clear? So take one isometric dot sheet and practice the steps we have shown clearly. So how to draw first line, how to draw first, second, third, like that you draw it. Clear? See the next one here. So this figure now we have to draw on the isometric dot sheet. Let us see now. First draw the vertical line, horizontal, parallel line, join them. Yes. Join it. Yes. So this is how we can draw the given solid 3D figure in isometric dot sheet. Clear? See the next one now. First draw vertical, parallel line, join them. Yes, this is the figure. It's clear? See the next one now. Yes. Okay, now let us see the next question here. Draw a cuboid on the isometric dot sheet with the measurements 5 units, 3 units and 2 units. Okay, so we have to draw one cuboid with measurements 5 units, 3 units and 2 units. So here 1, 2, 3, 4, 5. 5 units the length. 1, 2, 3. 3 units the breadth and 2 units the height. So this is a cuboid with the measurements 5 into 3 into 2. Clear? See the next one here. Find the number of unit cubes in the following 3D figures. So we have to say how many unit cubes are there in this. So how many unit cubes are here? Let us see. This is 1. Okay. This is 1, 1. 2 here. Plus, if you take like this is 1, 2, 3. So 2 plus 3, 5 unit cubes are there. Unit cubes in the sense each measurement 1 unit. Clear? Understood? So here up to here. See, this is 1 unit cube. Second, third, down 4, fifth. Clear? See the next one now. So look at here. 1, 2. So like that, 1, 2, 3, 4 sides. So 4 into 2. And the middle one. This is the middle one. Plus 1. So it is 8 plus 1. Total 9 are there. 9 unit cubes are there. Clear? See the next one now here. So this is here 1, 2. That means this is a 2 by 2. 2 by 2 in the sense 4 are here. Plus, look at here 1, 2, 3, 4. 4 by 4, 16. 4 plus 16, 20 unit cubes are there. Clear? See the next one now. So here, this entire is 1 plus 1, 2. So 2 by 2 is 4 plus here it is 1, 2, 3. 3 by 3 is 9. So 1 plus 4, 5. 5 plus 9, 14 are here. 14 unit cubes are there. Clear? See the next one. Now what is the question here? Find the areas of the shaded region of the 3D figures. We have to say the area of the shaded. See here, this is shaded here. If suppose this comes here, then it becomes a cuboid of length 3 units and the breadth is 1 unit and the height is also 1 unit. So it is 3 square units. Understood? What is the area here? 3 square units. Got it? Now see the next one here. So here 1, 2. So total 4 sides. So 1, 2. So that is 2 into 1. Like that 4. And in the middle it is 1. So plus 1. So 2 into 1 is 2 here. 4 2s are 8. 8 plus 1. 9 square units. Is it clear? Now, see the next one now. So here, look at here, 1, 2. So this is 2 by 2. That means 4 plus 1, 2, 3, 4. So 4 by 4, 16. Already this has come. One top and one bottom. So 4 plus 4, 8. So this is 4 plus 12. That is equal to 16 square units. Understood? See the next one now. So here, this is 1 by 1. So it is 1 plus. This is 2 by 2. That is 4 minus 1. We have to subtract that. Plus. This is 1, 2, 3. So 3 by 3 is 9. 9 minus the above one is 4. So it is 1 plus 3 plus 5. So 4 plus 5, 9 square units. The area of that figure is 9 square units. Clear? See the next one here. Consider the distance between two consecutive dots to be 1 centimeter and draw the front view, side view and top view of the following figures. Okay, again we are using isometric dot sheet here. There is a figure given here. So we have to draw the front view, then side view and then top view. Let us see now. So we are drawing the front view now. That means the diagram appears like that when we look from front. And now look at the side view here. Look at the side view. This is the side view. And then if we look at from the top, so that is the top view. Clear? The front view, side view and top view. Clear? See the next question. So this is the diagram given here. Let us see now. First draw the front view. Now the side view. And now the top view. Clear? So this is front, side and top views, children. Let us see the next question now. So here, this is the diagram now. Let us see how to represent this. So the front view. Now the side view. And now the top view. Okay. So this is how actually we draw the top, front, side and top views by using isometric dot sheets. Okay, well children, just practice all these. Take isometric dot sheet paper and you can practice. So this is the easiest way to represent 3D diagrams on isometric dot sheet. So now we have some shapes here. For the following shapes, identify the type of shape and name of the shape. So we have to say whether it is 3-dimensional or 2-dimensional, and you should say what is the shape. Let us see, this is a square here. We know a square is a 2D figure. It is a 2-dimensional figure. Okay, so what is the name of the shape? It is a square. And what about here? We are seeing a cone here. So what is a cone here? The cone is a 3-dimensional figure. What is a cone here? Cone is a 3D figure. Even this is a cylinder, 3D figure. Now look at here, there is a triangle here. So triangle is a 2-dimensional figure. Clear? So let us learn about more shapes. So this is a cube here. We know a cube is a three-dimensional figure. And what we are seeing here is circle. A circle is two-dimensional. And here we are seeing a cuboid. So this cuboid, three-dimensional figure. And here it's a sphere. The sphere is also a three-dimensional. Remember, circle is two-dimensional, whereas sphere is three-dimensional. Is it clear? Now, so here we will see like different shapes. So we are seeing some combinations here. So combination of different shapes. So what is this combination here? See what you are seeing, we are seeing a tent here. So on this tent, if you can see here, this is a cone. What is this? This is a cone. And here, this is a cylinder. Clear? So a tent is a cone surmounted on a cylinder. A cone surmounted on a cylinder, remember. Whereas here, we are seeing a tin here. So what is a tin here? Tin is a cylindrical shell. See, we have one cylinder here. Clear? And one more cylinder here. And what we are seeing here? So this is a shell. So this is a cylindrical shell. And what we are seeing one softie, that is ice cream here. So what is this ice cream here? See, this is a cone. What is this here? It is a cone. This is a hemisphere. Okay? A cone surmounted by a hemisphere. A hemisphere surmounted on a cone. Clear? And what we are seeing here, one photo frame. Photo frame, we are seeing one rectangle, outer rectangle, and here inner rectangle. So this is a rectangular path, what we see here. And now here we are seeing a bowl here. So what is this bowl? The bowl is a hemispherical shell. See? So this is a bowl here. A bowl is one hemispherical shell. Clear? So now we are seeing a tom on a pillar. So here, this is a cylinder. What it is a cylinder surmounted over a hemisphere. Cylinder surmounted by a hemisphere, or a hemisphere surmounted on a cylinder. So these are the different combinations what we are seeing, the different shapes. They are combined. Is it clear? Now, let us see here. We are discussing about three-dimensional objects. So these three-dimensional objects, they look differently from different positions. So what will be the different position? That means I'm talking about different perspectives. Like, you know, top view. If you can see from the top. We can see from the front. That is a front view. Even we can see from the side. So what are the three views that a three-dimensional figure will have? So this will have the top view, front view, and side view. Clear? Three-dimensional objects can be viewed from the top, front and side. Top view, front view, and side view. Is it clear? So, some figures are given here. Look at here. So, for each of the given solid, the two views are given. Match for each solid corresponding top and front views. The first one is done for us. So, here we are seeing a bottle here. See this side. We have a side view as well as top view. we have to match them. Let us see here a bottle. This is the side view and this is the top view of a bottle. It's clear. Now next what we have, a kg weight. We have a weight stone here. So let us see now, if we can look from the side, which figure matches here. So this one matches here. Clear? It matches there. And if we can see the kg stone from the top, so here it is 5 kg written. So it appears like this. This is a 5 kg stone. Is it clear? And then next coming to a flask here. So this will be the side view. If we can look from the side, the flask appears like this. And if we can see from the top, it appears like this, from the top view. And then we have cup and saucer. So cup and saucer from the side, it appears like this. And from the top, if we see, it appears like this. Is it clear? And then we have a container. So this is the side view of the container. And if we can see from the top, this is the top. So you have to imagine the figure and how it appears when we view from the top. It's clear? So remember, if it is a three-dimensional figure, with respect to different positions, it will have three views like top view, front view and side view. Is it clear? For each of the given solid, the three views are given. Identify for each solid the corresponding top, front and side view. We know we just discussed actually a three-dimensional object can be observed with respect to the position of the perspectives. Like we can observe it from the front, from the side and from the top. So there are some objects given here. So let us see, by looking them, we have to say what view it is. So an almirah is given here. Look at here an almirah, what we are seeing, this is a front view of the almirah. And what about here? This almirah, like this is a side view. And this is going to be the top view. If we look from the top of an almirah, it appears like that. It's clear. And then we have a matchbox given here. So there is a strip. Generally, the strip is a side view. And what about here? This is the front view. And this is the top view. Clear. And now there is a TV set given here, television. So television, this comes under a front view. And what about here? This is a side view. So TV appears like that when we look from the side. And this is the top view. Clear. And then there is a car given here. So this is a front view of the car. If we look from the front, the car appears like this. And this is a side view. And this is going to be the top view. Clear? So every solid, like a three-dimensional object, will have, when observed from three different positions like front, side and top, how they appear. So a few of the examples we have taken and we have explained. Now let us move to the next one here. For each given solid, identify the top view, front view and side view. So this is going to be a very, very important one here. So some objects are given here. So how we can say, like these objects, First object you look at here, there is, when we are looking from the front, we are able to see only two boxes. Is it clear? So this is going to be the front view here. Clear? And when we look from the side, see, we are looking from the side, we are able to see only these two. So this is going to be the side view here. And the first diagram, when we look from the top, so this is going to be the top view. Clear? And then look at the second diagram carefully here. So these two, like, these two, if you observe, when we look from the other side in the sense even this side, when we look from the other side, we are able to see the two boxes there. So this is going to be the side view here. And what about the next diagram we are seeing here, the three? So if I look from here, I'm able to see this, this and this. So we can see this is the front view here. And when we look from the top, we could see these three and the side one. So this is the top view. Is it clear? Now, look at the next one here. See, there are three boxes and one more box is like this. So when we are looking from the side, okay, when we are looking from the front, how it will be see? We could able to see these three and this one. We are looking from this front. If I look, I can see the three and this one. So where is this? Here it is. So this is the front view. So when we look from the side, we are able to see three boxes. So this is going to be the side view here. And when we look from the top, we could able to see this and this, the two boxes. So this is going to be the top view. Is it clear? Now look at the next one here. So there is the diagram given like this. You see, if we look from the side, what we see, we could see only the two. So this is going to be the side view here. And what about this? See, if we look from the front, we are able to see these three boxes and one more here. So this is going to be the front view. And obviously, when we look from the top, we could see this, this and this. So three boxes we can see, that is a top view. Just try to imagine the diagram in your mind when we look from the top, what we are going to see. Look at the next one here. So these two and this one. Clear? So if I am looking from front, what I am able to see here, if I am looking from front, I am able to see this portion, these two. Clear? When I am looking from here, I could see this two and these two. When I am looking from the side, what we can see from the side, we can see only two boxes and this is the other. Is it clear? We can look from this, and when we look from the top, what we can see this, this and this. So now look at here, when we are looking from here, what we could see now. So this is going to be the front view here. So when we are looking from the top, it appears like this. So this is going to be the top view. And this is going to be the side view. That's clear? So when we are writing the answers, you have to imagine the diagram, like when we look from the side, what we are able to see, what is visible. So that shape you have to identify and you have to mark it. Clear? Okay, well children, our Classroom TV has a website www.classroomtv.in. So in that website, all the exercise problems from each chapter of your textbook or detail is solved and it is loaded in the website. Apart from that, you also find the practice papers from each chapter. So log into that website, solve those papers and improve your knowledge. God bless you all. We'll see you in my next class. Stay tuned and do not forget to watch classroomtv.in.